Okay, in this problem we're asked to determine position and velocity from acceleration. We're given the acceleration function, a of t is equal to sine pi t. We're also given that v, when we plug in a 0 into our velocity function, we get an 11, and when we plug in a 0 into our position function, we get a 10. Okay, these will be useful later. Okay, so let's start by recalling this. If we want to find v of t, then it requires taking the antiderivative of a of t. Okay, so the antiderivative of acceleration is velocity. Okay, so that's our starting point right there. Okay, so we integrate to find v of t. We integrate sine pi t dt. Now to do that, I'm going to use a u substitution. U is equal to pi over t, or excuse me, pi t. So du is equal to pi dt. And if we divide the pi over, we get du over pi is equal to dt. Okay, so this is equal to the integral of sine. Instead of pi t, we're plugging in u. And then instead of dt, we'll do du over pi. Okay, which we can bring that out to the front. Sine u du. Okay, now the antiderivative of sine is negative cosine. So this gets us 1 over pi times negative cosine of u plus c. And if we plug in for our u, and I also brought the negative out to the front here, cosine, and instead of u, I will do pi t plus c. Okay, so we get v of t is equal to negative 1 over pi cosine of pi t plus c. Now, obviously, we can't just leave it as plus c. We need to figure out what the plus c is, and that's where this initial condition helps. It says if you plug in a 0 into the velocity function here, you'll get an answer of 11. Okay, so if I plug in a 0 in place of t, I'll get an answer of 11. So it's 11 is equal to negative 1 over pi cosine of pi times 0 plus c. Okay, pi times 0 is 0. So cosine of 0 is 1. Okay, so we get 11 is equal to negative 1 over pi times 1 plus c. Obviously, the times 1 it remains the same. So if I add this over to the other side, I get 11 plus 1 over pi equals c. That's my c, which I'm going to replace this with. Okay, so that gives me my velocity function is this. V of t is equal to negative 1 over pi cosine of pi t plus 11 plus 1 over pi. Okay, so that's the first part of the problem. We found the exact velocity function using the acceleration and the initial condition that we were given. Okay, now let's go on to the next step and find the position function. Okay, now recall that in order to find position from velocity, it's the same thing as we just did when we found velocity from acceleration. Okay, the position is the antiderivative of velocity. Okay, so we are going to take the integral of negative 1 over pi cosine pi t plus 11 plus 1 over pi, all with respect to t. Okay, and we are going to use the initial condition, and I'll recall our initial condition that we're going to use this time is s of 0 is equal to 10. Okay, I'm going to split this up into 3 separate integrals, or maybe just 2 separate integrals. 3, it doesn't matter. Watch this. So I'm going to bring the negative 1 over pi out front, and I have the integral of cosine pi t dt. Okay, that's my first integral, and then I could have the integral of 11 dt and the integral of 1 over pi dt. Okay, so obviously these two are pretty easy. This one becomes 11t, and this one becomes 1 over pi t. Okay, I will circle back to those after I get the answer to this. Okay, so this is going to require u substitution just like the last time. u is equal to pi t, du is equal to pi dt, divide the pi, du over pi is equal to dt. Okay, so that gives us negative 1 over pi times the integral of cosine of u times du over pi. Okay, I'm going to bring the pi out with this other pi to make pi squared on bottom. Negative 1 over pi squared times the integral of cosine u du. The integral of cosine is sine, or the antiderivative of cosine is sine. So we get negative 1 over pi squared times sine of u. Okay, and then that's plus c. If we substitute in the u, we get negative 1 over pi squared sine of pi t plus c. Now, keep in mind that this is only this part, right? We said we were going to swing back and grab these two. These two were part of the integral too, so I have to tag those on to the end. So I get the position function, which is s of t, is equal to negative 1 over pi squared sine pi t plus 11t plus 1 over pi t plus c. Okay, so now that we've done that, we need to figure out what c is. Remember, we have s of 0 equals 10. So 10 is equal to, and I'm plugging in a 0 everywhere I see a t. So negative 1 over pi squared sine of pi times 0 plus 11 times 0 plus 1 over pi times 0 plus c. Okay, obviously these terms go away. They're 0, right? And sine of 0 is 0. Okay, so basically all these terms go away, and 10 is equal to c. Okay, so my answer is s of t is equal to negative 1 over pi squared sine pi t plus 11t plus 1 over pi times t plus 10. And that's our position function that we found starting with the acceleration and using initial conditions of v of 0 is equal to 11 and s of 0 is equal to 10.